Good morning, and thank you for very much the introduction. And my research theme, research target is Rebar corrosion, and especially the bond effect, bond deterioration effect on structural performance. So, firstly, let me show the Rebar corrosion process and the phenomena induced by Rebar corrosion, firstly. And after corrosion starting, the corrosion product generates the expansion force and induces the crack to concrete around rebar. Once the crack reaches to the concrete surface, the deterioration factor, such as chloride ion, can easily penetrate, and the corrosion progress is accelerated. And finally, the spoiling of cover concrete occurs, as you know. In this sequence, the rebar corrosion causes the main three phenomena: the section of rebar, the corrosion crack, and bond deterioration. And the section of rebar has influences the structural performance directly, such as reduction of yield load and the load capacity or the ductility. And crack induced by corrosion product causes the change of stress transfer mechanism or the bond fracture failure in the most serious cases. And it is this crack is generally horizontal crack along rebar. And the change of surface condition of rebar induces bond deterioration between rebar and concrete. So the bond is the important mechanism of the reinforcement concrete. So in this research, the mechanism of bond deterioration by rebar corrosion was focused. So let me organize the components of bond, the three factors: mechanical resistance, and the friction, and the chemical adhesion. In these factors, mechanical one by interlocking between lug of rebar and concrete is dominant. So for achieving the sound bond, the deformed bar is used widely. The friction is the shear force between rebar and concrete, and it is considered that the corrosion product gear around the rebar surface lose it by rebar corrosion. And the chemical adhesion is generated by the cement, but it is lost immediately by the rebar corrosion. And the mechanical bond is led by interlock between lugs and concrete. The rebar corrosion changes the rebar surface shape, but interlock has possibility to be kept. In general, it is said that the rebar corrosion causes the bond loss. However, it is just under the overall image, including these three phenomena. So the consideration focusing each component of bond were few. So this study focused on the dominant factor interlock effect, and aiming is the investigation on the influence of intercondition change on structural performance of RC members from experimental and analytical approach. So this slide shows the experimental setup. The static loading test on beams with different interlocking conditions were conducted. The parameter was the interlocking area, 100%, 50%, and 0%. To achieve 50% interlocking area, this beam did not have the cover concrete from the casting. It means the bottom half surface of main rebars were exposed like this picture. And in this area, did not have contact with concrete. In 0% interlocking beam, the round bar was used as main rebar, so it had only bond effect by chemical adhesion and friction action. All beams were designed to fail in shear to catch bond performance. So in general, the bond deterioration causes the stiffness reduction of the crack dispersion, or the increase of the shear capacity due to the tidal formation. Now, next is the experimental result. This graph shows the load diffraction curve, and this figures is a crack pattern. The stiffness of the 0% case was greatly lower than sound case after cracking, and the more rigidity declination occurred due to the slip between rebars and concrete from 140 kilonewton. The number of cracks was lower than other cases, and the failure mode of this case was changed to anchorage zone failure from the shear failure in other cases. This is because a tie latch was formed in the beam. The tensile stress was distributed uniformly on the main rebars along as a tie by bond loss, and the strong compression strut was formed this area. In 50% case, the stiffness after crack decreased slightly compared with the sound one, but the rebar slip behavior was not observed, and the crack pattern, crack behavior or failure mode was similar to sound one. So it is considered that the bond performance of 0% interlocking case reduced significantly, but the bond declination in 50% interlock beam was slight, even though the interlock area was half. In this study, the analytical investigation was conducted from reproduction analysis and the analysis supposing more realistic state. For analysis, the 3D FE analytical system COM3 is used. This system is based on the smeared cracking model. This figure shows the overall view of the quarter cut FE model in this study. In this model, the main rebar shape, including lag, was modeled precisely by the solid model as a steel element and embedded in concrete for focusing on the interlocking effect well. And two-dimensional joint elements were placed between the steel and the concrete. So it means the interlocking effect are divided from other bond factors, that is, reproduced by joint element. In the original concrete model in this system, concrete components such as a cement matrix and aggregate are averaged as a concrete element. However, for this model is not appropriate in this case because the mesh size is much finer. Therefore, in this model, the concrete part was divided into two types of elements, the mortar element and the gravel element, and randomly placed based on the volume ratio from mixed proportion in experiment. This slide shows a comparison experimental result with analytical result. In 100% and 50% cases, analysis can reproduce experimental result well, but the 0% case was different from 140 kilonewton. The crack pattern and failure mode change in 0% case can be reproduced well. So in analysis, the load dropped in 140 kilonewton once and rose again with low rigidity. It is caused by the rebar slip in all area in axial direction once. In contrast, in experiment, the rebar slip was the very local and dynamic phenomena, and the slip and stop were repeated locally. So dynamic analysis should improve the accuracy in 0% case, but the other cases with interlocking by solid model was reproduced well. So the bond model, the reproducing chemical and the friction factor has a room for improvement, but the interlock by solid model has high validity. So it means that the contribution of interlocking is dominant in three components of bond. To investigate under more close to axial condition, three viewpoints, the lag loss location, the reduction of lag height, and the non-uniform lag loss in axial direction were considered. The case one supports the corrosion process. The rebar corrosion is caused by the penetration of the deterioration factor from concrete surface. Therefore, the rebar corrosion starts and progresses from the rebar area crossing to the concrete surface. In this study, the ultimate case that part of area was perfectly corroded and round shape, and that the other area has a sound lag was analyzed. The other corroded area, three cases were set like these figures, and the red part shows the round shape area. And case 2 aims the condition in progress of corrosion, that is, the section loss of rebar occurs by corrosion, but the roughness by reduced lag shape was remained. The three levels were set, beam with 75%, 50%, and 25% of lag height were set. And case 3 focused on the non-uniform corrosion in axial direction, and the cases that complete lag loss and the sound area existed alternately were analyzed, and 3.5 centimeter and 9 centimeter of intermediate length were set. First, let me introduce the effect of lag loss location. Basically, all cases show the stiffness reduction and the crack concentration trend, and its reduction degree has the corresponding with lag loss ratio. And the load dropping by rebar slip was observed in only side 0% case, this case, which has two complete round parts. So it can be said that the complete lag loss reduces the bond performance significantly, but rebar slip can be prevented if sound interlock is remained in a part of rebar surface in each rebar. Next, let's focus on the reduction of lag height. The green and orange line, cases with 75% and 50% of lag height, show the almost same behavior as sound beam in load deflection curve and the strain distribution. On the other hand, the case of 25% of lag height, the GG declination and the crack concentration, and the uniform rebar strain distribution were clearly observed. So bond was deteriorated significantly, although the clear rebar slip was not observed in this case. In 20% of lag height case, the contact area by lag of rigor and concrete in the pull-out direction is too small, like this figure, then the bond force degraded. From this result, it is estimated that the progress of corrosion in the certain lag loss ratio or the surface roughness condition, the rapid bond loss occurs. So the bond deterioration is not gradually declination with corrosion progress. The last point is the ununiform loss of axial direction. Looking at the load displacement curve, the slight rigidity declination occurred, and the starting point of that become lower with the increment of intermediate lengths. However, the rebar slip behavior or the behavior change as former bond deteriorated case were not observed in both cases. So from this result, when a part of lag is lost and some rebar area has no interlocking, if the other area with interlocking can, if the other area has a sound interlocking, this part can resist throughout load, and the overall beam, the bond can be maintained. This slide shows a summary of outcomes from investigation of bond deterioration by interlocking loss as a summary of this research. These figures shows the relationship between bond condition and the corrosion progress. In the sound condition, the three bond components can work and the interlocking effect is dominant. And under the slight corrosion state, the chemical effect reduces due to the corrosion product gel, but the interlocking and the friction effect can be kept. After the corrosion crack, the corrosion product can leak from crack, so gap between rebar and concrete is generated. In general, the bond is often assumed to be lost in this state, but the interlocking effect can be maintained because the contact between lags and concrete exists according to this research. When the contact is completely lost, or when concrete around rebar is fractured, the significant bond loss occurs. But even under this condition, if sound bond area existed in other part of rebar in axial direction, it can resist throughout force and the bond can be kept as a whole of member and the rebar slip can be prevented. As a whole view, the bond can be maintained as long as the interlocking between lags and the concrete remains in some area. Even if some area has serious bond deterioration, if the other area keeps interlocking, the total bond can be maintained. This is the end of my presentation. Thank you for kind attention.
Thank you for this many very interesting presentation. We will let some questions from the audience, so don't hesitate to ask questions in the Q&A zone. We have a question from Omid. So he say, what was the concrete compressive strength of the beams, and what was the concrete cover?
Okay, the compressive strength of beams is about 40 megapascal, and yes, the 40 megapascal, and the tensile strength is the 3.9 megapascal, and the concrete cover means the the concrete, the bottom part, under the main rebar. So it is, in general, it is not, it doesn't contribute the structure performance.
Thank you. I may have one question in page 5. Can you tell us more about the adhesion law between the rebar and the concrete?
Sorry, your voice is a little.
So can you detail the adhesion law that you considered between rebars and concrete?
The bond state.
Yes.
Between rebar and concrete. Yes, yes. In 0% case, the round of rebar, round bar is used to main rebar, but no treatment for rebar surface, so the chemical and the friction action exist, I think. And the 50% and the 100% case, the same deformed bar was used. So the difference is only the contact area of the between rebar and concrete.
Okay, thank you. We have a question from Dave Merritt. So on slide 12, the last two diagrams say 20% loss. So the last slide appears to show more loss. Is the last 20% figure correct?
Yes, the 20% is just the just a very theoretical just a theoretical corrosion ratio means that it is if the corrosion section loss ratio is higher than 20%, the diameter including lugs is lower than the diameter of the not lug area of rebar in the standard. But in actual, the corrosion product can expand the concrete, so the space of this area will be expanded. So maybe the more in lower state, the lower corrosion ratio, this situation can be achieved, I think.
Thank you. We have another question from Marco Basaledella. Sorry. So on the construction site, very often the rebars get some rust. In such a case, do you think that the chemical and frictional bond are already lost? Then the rebars are working properly only due to the interlocking mechanisms?
I think the friction can be work. It is if the rust cover the rebar before casting, because the rust is not liquid and solid, so contact between concrete and steel and rust can be kept, I think. But the chemical adhesion is lost in this state. But the most dominant factor of the bond was interlocking, I believe. So, maybe if compares the pure bond resistance, if rebar is slightly correlate or the sound rebar, same result can be get, I think.
Thank you. I have a question. You generated the aggregate during the simulation. What is the rest of generating aggregate? How did you did it? And how did you calibrate the parameters for the mortar and aggregate?
Yes, so basically the gravel element is basic on the concrete behavior, but the specific gravel behavior, no tension stiffening, and yes, so I said tension stiffening is very low tension stiffening, and for the strength, the compression strength and the tensile strength or Young's modulus is based on the catalog spec from factory.
Okay, we have a question from Gaël Leblois. You can ask it by yourself if you want, Gaël.
Sure. Thank you, Ryota, for your presentation. I have a question. In your test setup for the 50% interlock case, you choose a reduction of the concrete cross section. Okay, and my questions are how these can influence the wall resistance behavior of the beam, especially as you mentioned that there is shear failure of this portion. Did you observe also this bonding, like an uplift effect from the fact that there is no cover of the concrete? And why did you not choose to have a rebar with a lug on the top and a round bar on the bottom?
Okay, actually, I want to select your suggestion, but it is a very difficult to achieve because in my past research, if I grind the lug, but it is not factorial level, so some roughness should be remained, and some pull-out resistance can be kept. So I selected remove the cover concrete, and for achieve this situation, I set in analysis that this case was set in analysis. Almost same condition, but the difference is the cover concrete is exist or not. Of course, experimental and analytical approach is different.
Okay, thanks. And I have an additional question, if you're okay. Did you study, even numerically, the influence of the result for the rebar diameter, or it is covered with the lug 8 analysis that you've done?
For the influence of the rebar diameter, I don't conduct for the beam analysis, but for simple analysis, the tensile test and reproducing analysis is conducted like this. I conducted the experiment and both of experiment and analysis, and as one parameter, I set the rebar diameter, and of course from lower the rebar diameter, the lug height is lower, but the trend is almost same. If the lug height is lower than the 50% in the standard, from the standard, some the low tensile resistance strength were good, basically as a trend. And sorry, I missed the next covered by. Yes, is that make sense?
Yep. Thanks.
We have another question from Aurelio Mutoni. If you want to ask a question by yourself.
Yes, it's a matter of understanding. In the test that you have presented, when you talk about 50% loss,
Yes.
I don't understand exactly if you are talking about 50% loss of the lack height, or in my opinion, it's more an effect of spalling. And I'm not sure that this is exactly the same as the effect of lag height.
Yes. So
because it's more or less the same as when you remove the cover, and then the bond strength is very much related to the confinement effect of the stirrups. And this is not the same as the loss of the lags, in my understanding, but perhaps I don't understand exactly.
Yes, so the first the effect of the spoiling the cover concrete. In this case, the cover concrete is removed from casting, so the effect is only to the low cross section. So the initial stiffness is lower in
sure.
this graph. It is difficult to catch, but the initial stiffness are a little bit small. And I also conducted this beam and same geometry, but there is no stirrups case. So in this case, the stirrups kept the main lever to keep main lever contact in upper area, but if there is no the stirrups in the middle stage of loading, the main lever
can move, and then you
can move the
almost lose the bond strength.
Yes. So So
I think that I fully agree, and I think one should differentiate the two cases. And in my opinion, the 50%, what you describe here as 50% interlock, is more the effect of spalling, and is perhaps not so much related to loss of lags. And with respect to the effect of loss of lags, in my opinion, this phenomenon is very much related to another phenomenon, which is the development of longitudinal cracks along the reinforcement bars.
Yes.
I don't know whether you investigated this phenomenon. There are models, there are even mechanical models describing the effect of longitudinal cracks. And if you have a longitudinal crack along the bar, then you lose partially the contact between the lags and concrete, which means that you will have reduced bond strength. For instance, a PhD student of mine has investigated this some years ago. There is also a publication on this by
yes.
in actual by Branchen.
Yes, in actual, my PhD team is more large, and the development of an analytical model of the corroded still. And this is the first step, and I pick up the only one effect, the mechanical contact. And now I conducted the next step, the effect of corrosion crack, the longitudinal crack. And now the new experiment, the how say the tensile, Rebar tensile test with concrete with the corrosion crack is ongoing, but I don't have result now, so I'm sorry for not introducing it
I
today.
understand, but I was mentioning something different. If you have a longitudinal crack, then you will have reduced contact zones between lax and concrete.
Yes.
And this phenomenon is very similar to what you wanted to investigate, which is the loss of lax height.
Yes. Yes. So
which means that you could easily adapt the models which exist for the longitudinal cracks to the case of loss of lax, in my opinion.
Thank you. In the final stage, I want to integrate the long corrosion crack and the selection loss. Yes.
Yeah. It's a very interesting discussion. Unfortunately, we are too late, and we cannot continue this discussion, but it would be very interesting. Sorry.
Thank you very much.
Thank you. Thank you for